Hello, today we're going to be talking about inequality solutions. So there's two very important pieces of information you need to be aware of. Solutions make inequalities true, and that shading represents solutions. So the first question says, which of the following are solutions to the inequality 3x plus 4 is less than negative 5x minus 6? And I have four choices here, some of which are going to be solutions and some of which are not. It's our job to test them all and see which ones work and which ones don't. So I'm going to start by testing negative 10. How we do this is by plugging in our value, negative 10, into every x value provided in the inequality. So I'm going to start by giving myself a home for my value that I'm going to plug in. I do this by placing parentheses and waiting to drop in the value we're testing. So I'm going to split it down the middle just a little bit so that I know what side is on the left and what side's on the right. So I plug in a negative 10. And then I do math. You can use your graphing calculator for this if you need, or you can just work on doing the math in your head. So this winds up being negative 30 plus 4 is negative 26. On the right side, I also have to plug in negative 10, and I wind up with positive 50 minus 6, which is 44. So I evaluate this nice and in line and determine, is negative 26 less than 44? And the answer is yes, it is. So this is true. What that means is that the value you plugged in is a solution. So we're going to wind up doing the same process again and again for each value we are plugging in. So I'm going to erase just to save myself some room and leave myself the space that I chose for plugging in our value. So now I'm going to test out negative 4 and see what happens. So 3 times negative 4 is negative 12, plus 4 is negative 8, and determine if that is less than positive 20 minus 6, which is 14, which in fact, that is true. So that tells me the value I plugged in is also a solution. And we're going to try the next two. So you wind up with zeros in place of the negative 4, also in place of the x in this case. You wind up with a positive 4 is less than negative 6. That's not true. Any positive number is not smaller than any negative, so this is false. That tells me that the number I plugged in is not a solution. And last but not least, we're going to do the same process again, but with plugging in 5. You wind up with 15 plus 4 is 19. And is that less than negative 25 minus 6, which is negative 31? No, that's not true. It's false. 5 is not a solution. So there are two other types of questions that they are going to ask you when it comes to inequalities and their solutions. Both of which are going to be determine the largest integer solution or determine the smallest. So you're probably going to have to do some solving of some kind to get to this point. I'm only going to talk about what you have to do from here forward, okay? So if I have determined the largest integer solution, the best strategy is once you've solved and you arrive at something like x is less than 3, you're going to wind up graphing it because that's going to give you a visual that's much easier to determine what the largest or smallest integer is. So on my number line, I'm going to use an open circle and shade to the left for is less than. And now I have to bring in this idea of shading represents solutions. So which is the largest integer that is shaded? Well, 5 isn't shaded, 4 isn't shaded, 3 is also not shaded, so 2 winds up being your largest. Similarly, if we have x is less than or equal to 0, I'm going to shade in the circle for 0 and also shade to the left. I can check again as well for my largest. I'm going to start from the larger integers on the right. Even the ones off the line, like 4, 3, are not shaded. Neither is 2 or 1. 0 is. So this is an example of when you can actually choose the endpoint to your inequality. Whereas here, since 3 is not shaded, I cannot choose it because it's not a solution. I go right up to it, but I don't include it. So in this example, 0 is the largest. So you're going to use the same process for when you have to determine the smallest integer, but you're going to start from the left because that's where all of your smaller numbers are. So I'm going to graph x is greater than -2 by open circle on the -2 and shade to the right. And now I check from the left side. -5 is not a solution, neither is -4 or -3. Neither is -2 because -2 is not shaded. -1 is the first integer from the left that is shaded, which represents my smallest integer solution. And finally, x is greater than or equal to 1 gets a closed circle at 1 and shaded to the right. -1 is not a solution, 0 is not a solution, 1 is because it is shaded and I can be equal to it, hence 1 being the answer. So 1 is your smallest. I hope you have a great day. Bye.